Welcome to myprojectbazaar.com. Our project title is a data mining approach combining k-means clustering with bagging neural networks for short-term wind power forecasting. So now we are going to discuss about our process abstracts. Wind power forecasting is significant to guide the dispatching of grid and the production planning of the wind farm effectively. So the intermittency and volatility of wind leading to the diversity of the training samples have a major impact on the forecasting accuracy. So in this paper, to deal with the training samples dynamic and to improve the forecasting accuracy, a data mining approach consists of k-means clustering and bagging neural networks is proposed for the short-term wind power forecasting. So based on the similarity among the historical days, the k-means clustering is used to classify the samples to several categories and which contain the information, meteorological conditions and historical power data. So in order to overcome forfeiting and instability problems of conventional neural networks and bagging based ensembled approach in integrated into the back propagation neural networks. To confirm the effectiveness, the proposed data mining approaches examine on real wind generation data traces. So the simulation results show that is the obtain better forecasting accuracy and another baseline of existed short-term wind power forecasting approaches. Next we are discuss about our process flow diagram. So this is our flow diagram. First of all, we are going to load our data set. So after loading the data set, the next process is data pre-processing. So data pre-processing is the data mining techniques that involves the raw data into understandable format, and data pre-processing is a prepares the raw data into for further processing. Okay, so now we are going to pre-processing our data set. Now all the null values or irredundance and irrelevance value should be neglected here. After that we have to load our data set into the database. So after data pre-processing, then we have to select the next process, that is feature selection. So feature selection is also known as the variable selection or attribute selection. Okay, here we have to select a particular attribute selection for our next process. Okay, so now here we have to find out the important features which was used in the future processing. So after feature selection we have to made a k-means clustering. So in this k-means clustering is one of the data mining techniques. Here we have to find out the k equivalence distance between the datas and also find out the frequent items. Okay, so in data minings we have to split out two. So in this paper we have to forecast the wind power generation. So in this paper mention, the k-means clustering is made up of which is divided into two types. The one is based on the weather conditions. So we have to cluster our data set with the weather condition. So first one is temperature. So depending upon the temperature, what kind of accuracy will produce for wind power generation, and so another one is humidity. So in temperature we have to cluster our data set into particular state wise, and then humidity. So here we have to find out the large amount, how many amount of wind power will be produced on the particular temperature and humidity. So after finding the k-means clustering, we have to apply the SDR. So this is one of the linear regression algorithm. Support vector regression algorithm we have to implement. So here we have to find out the frequent item set. So after finding the SDR, then we have to find out the voltage power estimation. So so our voltage will be calculated is based on the days. Okay, so as per the day, how many power will be produced, it will be estimated. After that we have to make a results. So we have to find out the RMSE results and the MAE results, and finally we have to forecast the wind power generation results. So after these three results should be in we have to show in the graphical format. Let's we see the demo of our process. So just homepage.java, just run click and give run file. So a data mining approach combining k-means clustering with packing neural networks for short-term wind power forecasting. So this is our process title. Just click. So this is the main page. Here we have to load our data set. So just click fetch data set and select the data file and display the content. Then click next. So this is the pre-processing frame. Click loading. Our data will be loaded, and this is the raw data. So pre-processing means we have to remove our null value and fill with the corresponding values. And next, this is the feature selection process. So just click feature selection. So we have to take out global active power and global reactive power and voltage, temperature, state. This is the feature selections of our process. So click next. So this is the pre-processing data, and click clustering. So we have to cluster our data set into the weather informations. So we have to split out our temperature, humidity and cloudy. Okay, then temperature clustering. So we have to cluster our data set with the help of temperature clustering. So just click the temperature. So this is the in particular temperature we have to find out, and the vector global reactive power also calculated. So then we have to click the low power temperature areas. So in these areas the wind power generation will be very high. Okay, then the next process is humidity based clustering. So just click the humidity of our data set. Okay, then after humidity calculation we have to cluster our humidity data. So in humidity 45 range, these areas will be have a large amount of wind power generation will be produced. So in 85 means the wind power generation area is very low. Okay, the next process is apply SVM. So our results will be calculated as based on the states. So in Colorado, the maximum amount of the power will be produced on the regarding voltages. Okay, so next we have to predict our results. So mean absolute error and RMSE results and forecasting results. Okay, so we have to show our results in the graphical format. So this is execution time in an x-axis taken as threshold value of the wind power generation, and MAE or MSE and forecasting results, and y-axis is taken as a time. So demo is completed. Thank you for watching this video.